Okay. Hi, hello everyone. I'm Michalis Kamburelis and welcome to the presentation about Castle Game Engine. So, we will jump very soon into actual live demos of the engine, but before this, like a quick words of introduction. So the engine is fully open source, as you would expect. We support 3D and 2D games alike. We really support both those kinds of games, and I will actually show you the demos of both those kinds of games along with the presentation. We support many asset formats. This has been like one of my goals when developing the engine, to support many asset formats, to like make it available. Whatever tool you use to create your assets, you will be able to create assets using for our engine. So in particular, we have excellent GLTF support, and we use XVD nodes to express pretty much everything that you see on the screen. We also support Spine JSON, Collada, Wavefront OBJ, and actually many other formats. So we really try to be versatile when it comes to that. We support many platforms, in particular desktops, which means Windows, Linux, macOS, FreeBSD, and actually a few more that are supported also by our compiler. Mobile, which means Android, iOS, and during this presentation I want to actually show you how the game running on Android, how it looks like to compile the game, to build the game on Android using our engine, and I will actually show it running on the Android to you. And we also support Nintendo Switch, console Nintendo Switch. We as a language that is being used to develop the engine and also your games, we use modern object Pascal. Now, is this kind of like raises some eyebrows? Well, I will address it later into the presentation. For now, basically, like it's kind of a cool modern object-oriented language with generics, classes, interfaces, everything you would like to have to develop a large application. So it's, I will say more about it during the presentation. We will actually go also in and modify some code. Okay, so what about version? In Debian right now contains the version 6.4, sorry, which is our last stable release. But since 2 years now, we have been working on a new version of the engine. Right now it's called 6.5, but it will become, once released, version 7.0, which, as you can see, well, it is a major release, and we have added many new features to the engine since then. But in particular, we will have the editor, which I will show during this presentation extensively. We also added excellent support for the GLTF format, which includes also support for the physical-based rendering. Physical-based rendering is also available in XVD version 4 using our engine. We also added the support for Nintendo Switch. We also added gamma correction and about 100, I guess, refactors and API improvements. And yeah, so many new features, many new graphic features are going to appear in the new version of the engine. So I'm going to show you a new version of the engine, not yet packaged in Debian. We are working on making it released, well, I guess as soon as possible. And when it will be released, I'm pretty sure that it will also be packaged in Debian soon. Okay. So, going forward, well, as I told, the engine is using Pascal as a programming language, and for this reason we use a free Pascal compiler, an open source Pascal compiler. It's packaged in Debian, and you can use the FPC version that is packaged in Debian. You can also download the free Pascal upstream latest version yourself. Various FPC versions work with our engine. We also advise using Lazarus, which is kind of an IDE, integrated development environment, for Pascal, and in particular integrated with the free Pascal compiler. You can use it, it's an IDE, it's an editor, it's a debugger, but basically you don't have to. I mean, you can actually just write Pascal code in any text editor you like. I use Emacs most of the time, so yeah, most of the engine was developed using Emacs, just like that. Okay, so those are the dependencies. Okay, and that is actually everything that I wanted to say as far as the introduction is concerned to the engine. And let's now jump to the actual live demo of how to use the engine and how to make cool stuff using the engine. So, once you download the engine, you go to our web page, you choose Linux, of course, and this results in a zip file that simply contains the engine source code and also the pre-compiled version of the engine editor and of the engine build tool and some other tools that are less important. And so right now I have already the engine installed on my system, so I will just run it and you will be able to see the editor. Okay, so once you have the editor running, well, the first thing you actually want to do is you want to look in the preferences and you want to see what version of the free Pascal compiler is detected. It should automatically detect whatever you have installed system-wide, but as I said, well, you can also choose your own version of the free Pascal compiler if you'd like to. And yeah, so this is something that you have to make sure that is correctly set if you want to build games using the engine. Well, once you have it, well, you start developing. So we go and create a new project. Let me start by creating a new project that is a very, very simple three-dimensional first-person shooter game. So I will choose some name for my project. I will do create project. And yeah, and this is the editor. So this is how it starts. At the bottom you can see the list of your files, the list of your assets, if you'd like to call it in that way. Data in particular contains all the data files that you will be able to load at runtime and to use, to show the user. And well, in particular, data contains something like custom user interface designs. And you can open any of them. In this particular template, it creates for you two user interface designs already, the main menu and the play, which is like the actual game state. So I will just open the actual game state. And it looks like this. So on the left, you have a hierarchy of your objects, which includes the user interface items. Which includes the user interface items, and you can choose any one of them. You can choose a few of them at once if you'd like to. And on the right side, you have all the properties of the currently selected object. And in particular, you have some basic properties, layout, everything else, events, and also all, which is like basically a tab. If you know everything about the engine, then you can use the all tab, and it contains everything you'd like to configure about this particular object. Okay, so as you can see on the scene, I have a few things. The most important thing actually is the full screen viewport, which, well, as I said, it fills the full screen, I mean the full game window. Just to show you that it's possible, of course, it doesn't have to be the full screen, like you can immediately make it and you can drag it around. So this is just a viewport. It's a two-dimensional control that you can move and drag around. Just by default, it's something full screen, okay? Inside the viewport, you have two things that are important. One is the navigation method, currently used inside the viewport. You can switch between various navigation methods using the menu, like the hamburger menu near the viewport, sorry. So you can choose the examine, fly, walk, and some other navigation methods. You don't have to use any of them actually. In a particular game, you can develop your own navigation method. There's not much to it. You just handle the keys, you just handle the mouse, touch input, whatever joystick, whatever you like, and you move the camera around in any way you desire. So those are just the navigation methods that are pre-configured for you, ready for you, but you don't have to use them. You can roll your own, or you can customize the existing ones. Okay, and of course, since this is a component, I have selected it, so I can also configure some properties of it already on the right side. For example, there's the move speed, like I can make it 10 times faster. Initially, it's actually 10, so I can make it 100, and then it's 10 times more than the average actually in this case. Okay, so this is one thing, like your navigation method inside the viewport. And well, the rest is items, which is like three-dimensional, in this case, three-dimensional models that you put in your game. And you can, of course, modify them and play around with them. But the most important property of a three-dimensional model is the URL, which basically says, well, what model to load. In this case, it's coming from a GLTF model of a level dungeon. This is the scene level. And for soldiers, for enemies kind of inside the game, well, there's another GLTF model that is being used to display them. Okay. I will show you how to add them very soon, just feels like a quick overview of what's happening here. Okay, so you have three-dimensional items here. In a two-dimensional game, you would also have two-dimensional items here, and actually you can mix 3D and two-dimensional games here because at the low level, there's no difference. There's just a different camera used for two-dimensional games conventionally, but that's it. I mean, you can mix and match 2D and 3D games as you'd like to. So this is the viewport. Well, aside from the viewport, there are also, well, other user interface elements, and those are just simple labels that you can customize. Well, it's just a label, it's a text, you can customize it in any way you'd like. For example, I can write here something well, random, as you saw. I can customize the color just to show you that it works. I can maybe change the font size, okay, so nothing fancy here, but basically we have a full library of user interface controls available inside the engine. We have buttons, images, groups for laying out controls. You have scroll views for putting out something that has a scroll bar on the side. So we have quite a full set of user interface controls that you can use. So as I said, well, at the beginning, well, those user controls, they are not, well, terribly interesting, right? So I'm just going to hide this label right now. I will keep this label existing, this frames per second label. It will be actually filled at runtime with code, with the, well, actual value of frames per second, which means how fast your game is. So this one will be actually useful for us when we run the demo. Yeah, so the viewport is also another user interface controls, and as I kind of emphasized, well, you can move and customize around things there. So let me actually do it. So you have, you can select things, you can move things, rotate things, scale things inside of the viewport. So let me just select a soldier and basically move it around a little bit. Let me also take this one. Let me move him like this, and let me actually, move the camera. Once you use this button, use components as a normal user, well, it means what it says. It means that now I can use the game and I can walk around the game using the navigation that I have chosen, which is right now the walk navigation with 10 times faster than default speed. So I can move around my scene and I can look around, well, and inspect everything. Whether it's for debug purposes or whether I just want to see how the user sees it, well, it's all the same, right? Okay, so what can we do more? Well, we can delete stuff, that's obvious, and we can also add stuff. So let me actually add something here. First, I will just add an empty scene. Let me make it inside the items. You can actually, of course, construct here a transform hierarchy when one item is a parent of another, and well, it's a transformation hierarchy. So transforming a group transforms everything inside. So right now I just added a simple scene and placed it at the top level to basically not mess around more than I need to. And let me just choose one 3D model. I'm going to choose the soldier again, but in like 5 minutes I'm going to show you actually how to create your own models in Blender, just to show you that it works like from scratch. You can create things as you'd like here. So here I just added another soldier. He landed there, usually initially at the 0, 0 position. So yeah, so that's how you add things to the engine. Now, if you want to, by default, the soldier, as you can see, is in like a T-pose because, well, his animation was not initialized yet. You can initialize the animation from code. This code is actually, this sample is actually doing that. Well, but I have not yet run the code. Right now, I'm only in the editor mode. But also, if you'd like to, you can actually experiment with animations already in the editor by switching the auto animation property. And so I can choose the stand animation, which is kind of a boring, it's actually a still frame, and I can choose the walk animation, okay? And still I can experiment, move things around and see, well, how they look like, okay? So sometimes it's useful just for experimenting, and sometimes actually it's useful to you just want to set the animation at the design time because this is the animation that is going to be played when user opens this model, okay? Now, one final note before we go further is that, well, everything you see here, well, those are not just some stuff inside the engines, stuff inside the engine. This is actually all those things that you see here, like Tcastle scene, Tcastle root transform, Tcastle viewport. All of those things are actual classes in Pascal that you can create using code. So, and this is a very important property of our engine. Well, everything you see, everything you design in the engine, it has one-to-one correspondence to what you actually do when using the code at runtime. All those things are just Pascal classes. And all the properties that you adjust here, like the URL, like the exists, like it means literally whether something is existing or not, whether it's visible and colliding or not. So all of those things are possible. You can access them from the from the Pascal code. You can access them by name. Here it comes the scene 1. Maybe let me make something like scene better name because I ran out of ideas. So basically now I would be able to access the scene using the scene better name in Pascal code. Yes, I'll show an example of it later. But the point here is that you can access the scene from the Pascal code, change its properties, And also, of course, you can add and create new scenes inside your Pascal code. So you are not limited to using the editor. Actually, you can make a fully functional games. We have done it in the past using without the editor at all, because everything that I talk about, it's possible to also achieve using the pure Pascal code without any visual editing, which means that you have the power of both worlds. You can design things visually, you can then tweak them from code, and you can add stuff from code, and it's all like mix it in any way you'd like, in any way that matches for your particular game. And yeah, and those things, as I started saying, those things on the right, where they are properties. Properties is a Pascal concept. It's also present in C#. Property is basically, it looks like a field, but actually it's something that can be backed by a getter and setter function. Okay, so it's a concept that also is present in C#, and it's a on language level, yeah, on a conceptual level, it's something present in every possible language, I guess. Okay. So this was a quick demo of adding some scene that was already existing in the project. Before we move on, let's actually compile this project just to see that it works, and then I will add some more tweaks to this demo, alright? So what I'm going to do now is I'm going to save this design, okay? This simply saves the file state_play.caster_user_interface. And this file will be read at runtime by the application. Okay, so how am I compiling the application? Well, I'm just going to do run, compile, and run. And that's it. I mean, that's how the building using the engine looks like. And underneath, it's actually calling the build tool, our custom game engine build tool, which is a simple command line application that can be used to build your application. Underneath the build tool, well, it calls free Pascal compiler, of course. So actually, all the heavy work is done by the free Pascal compiler. Well, none of what I'm describing would be possible without the free Pascal compiler. So the build tool is just a wrapper here around the free Pascal compiler, calling it, waiting for the compilation to happen. And once it does, it will run the application just as you would expect. Okay, and this is just a way to compile the application without even leaving the editor, the custom game engine editor. So I didn't yet run even any text editor or debugger, but I will do it soon. So just now, right now, only simple a demo that you can actually just visually design something, and yeah, you don't actually need to go and edit code before the basic template works. Okay. So this is the beginning of the game. This actually shows you the state main menu that you have not touched here. So it just has a very simple code that says that when you press the play button, well, it should go to the state play. And the state play is whatever you have designed. So it looks like this. And here you can see the soldiers with those crazy tweaks that we have made to them in code. The soldiers have in this template already a built-in logic to move around in this, well, not very intelligent way, but it's just a sample, something starting point for your own artificial intelligence. And in particular, this one guy that is in the back, well, this is the guy that we have added using the editor. I didn't yet plug here the artificial intelligence code, and that's why he's standing in place. And also not even being affected by gravity. Of course, in the engine we have integration with the physics engine, Craft. You have also our own simple physics, which allows you to turn on gravity very easily. Okay, so this is like very simple demo working. Oh, and the frames per second, as I kind of advertised, are also being updated. They are slow because I think the camera is just recording. It's 60 frames per second, no worries in an actual environment. Okay, so this was just a quick demo of running application on your Linux. Okay, so what can I do more? Well, let's try and actually do something in Blender and put it inside the game. All right, just to show that it's possible. So let me just run Blender. Okay, so once inside Blender, well, let's try to create a very simple level. Okay, so I'm going to delete the default cube and also the default camera. We don't need it, although we could use this camera as the initial starting point in the game, but in this case we don't really need it. So I'm going to create a grid. Let me make it a bit more subdivided, and let me also scale it up Let's go into the selecting vertices mode, deselect everything. Let's select some walls around. I mean, they are not yet walls, but we are going to make them into walls. Let's also select something in between, just because we can, I guess. Let's extrude them up. This is, I guess, good enough for the initial level. Let's delete here something to create, like, I guess, the simplest possible way to create doors. Okay, let's now create some columns, I guess, because why not? Again, simply extruding them up, that's enough. Okay, let's also, well, we have one lighting source here already. This Blender light source is going to be exported to the GLTF and is going to be used by the custom game engine. So let's take one, let's duplicate it a few times, I guess. All right, and maybe here, maybe here. Okay, 4 light sources, that should be enough. Okay. Now, the point that I'm trying to make here with the quick Blender demo is, well, not my mad Blender skills, but simply that it is really easy to make a model in Blender, and it's really easy to export it in a way that custom game engine can consume. Because, okay, what I'm going to do now is I'm going to simply export it to GLTF and load it into the engine, and really that's all there is to it. So let me save it somewhere. Let's call it level 2. Alright. Let's export it to GLTF. Now, the default GLTF export settings are actually okay, they work, but usually it's more comfortable to select GLTF separate options. It's better to do the kind of diagnose stuff. It's also usually nice to select apply modifiers if you have used any modifiers. I didn't, but just in case, well, I guess it's a force of habit. Right now, I kind of remember to always select apply modifiers. And actually that's it. Oh, almost, because now if I want to also export my light sources to the GLTF, well, I have to select this checkbox. Okay, so that's it. We have created a level in Blender. I can actually close the Blender now, and let's go back to the editor. So if I refresh this directory, okay, I have new subdirectory, new level that I have just created. The editor simply shows the normal file hierarchy inside the project. And here I have my Blender model, which is not going to be read by the engine directly. Instead, the engine is going to read the GLTF file. Now, if you want to preview the GLTF file or any other asset before putting it in the scene, well, one way is to, well, as you can see, I just click on it, and in the bottom right corner, I can see kind of a preview inside our engine. And it's a bit interactive, actually. I can move things around here. Another thing is to double click on it. And if I double click on it, then I run our View 3D scene, which is our full-featured 3D and some 2D model viewer too. And well, in this case, there's still not I can really do this simple model, but in general, it allows you to have, well, it allows you to play around with this model, to have a lot of like options to test how it looks like in various conditions. You can play animations here, you can even play around with light sources here, you can move them here. So it's a full-featured model viewer and a very, very small editor for models actually too. So right now, I just checked it as, well, okay, it looks correct, right? So let me put it in game. So let's add another scene. Let's also delete this scene level, the default one, because, well, I guess otherwise they would, well, try to compete, both of them trying to display the level. Now let's try to load the new level. I'm just pointing the engine to the GLTF file using the URL field. And that was my cat's tail, sorry. So I'm just pointing the engine to my level file. And really that's it. I have loaded the level, and it's automatically, it works without collisions yet. I mean, everything by default collides as a simple bounding box. So for a level that's not really what you want the level to collide, well, precisely using the triangles. So what you can select here is select dynamic collisions and rendering. Those two options make the, well, in the simple case, the rendering isn't really much needed, but in general, rendering means that the level is rendered using the efficient version of the Frustum cooling, and dynamic collisions, well, it means that the level collides as a set of triangles as opposed to a crude bounding box. So that's it. the level should already, well, basically be functional. I will run the game in like 1 second. Just one more note is that if you want the level lighting to affect also the soldiers, then you have to do one other thing, which means that you need to set the scene 1 in this case, which is our new level, as the main scene. Okay, so as you saw when I did it, the soldiers got lit by additional lighting that we have defined in Blender and that is now defined in the GLTF file. And that's it. Let's run it. Let's save this design and let's run it. All right. Yeah. The first compilation of the project, by the way, it compiles not only your game, but it compiles also the engine. Which means that you can actually have well. This was basically the simpler approach to do, and it also means that you can experiment with the engine freely within your project. But basically, my point here was that if you compile the game again, of course, it doesn't recompile the engine again, so it is much faster. Okay, so the game is running. Let's play it, and that's it. It works. I can move around with my still too fast camera, because that's how I started this presentation, and everything works. Okay. So this was a very, very simple demo that you can basically design your models in Blender, you can put it in the engine, and well, it works. Okay. What more did I want to present? So I wanted to add some button, and I wanted to control what happens when you press this button from code, which means that I also wanted to show you the source code of the project that we're making. So let's do it. Let's create a new button. This is very simple. I'm just using the add new button. Now the things look small here, but remember that by default the engine uses user interface scaling, which means that the things, well, they are small when they are displayed on a small screen, which the editor is right now simulating. But when the game window will be larger, then every user interface part will be larger too. This is fully configurable inside the project settings. Okay. So what I want to do right now is I want to anchor this button to the right side of the screen, because as you can see, anchoring it to the left side of the screen isn't really working for me. So I'm going to do this, I'm going to move it, and I'm going to do it like this. Now the button is anchored to the right side of the screen. Nice. I'm going to call it like show message, and I'm going to call this button show message. This is how I'm going to access this button from my code. I can make the font also, I guess, a little bit larger. By default, the button size is adjusts itself to the button caption, but of course this is configurable, as well as the look of the button. Like, it's just a default look of the button. You can of course configure it using images, using colors. So button is really something that is clickable. Like how it looks, it's completely configurable using a lot of options that you can see here. So like, don't worry about this default look of the button. You can customize it in many ways you like. Okay, so we've done it. We made the button. When I run the game, it will already show the button. There's really nothing fancy about this particular part of the demo. It's just a non-working button in this case. All right, let's hit play. And there's the button. I can click it. Nothing happens yet. Okay. So how to make something happen? Well, to make something happen, I want to open the source code, which is in Pascal, as I kind of mentioned a few times. Now, if you worry about Pascal being like an old language and so on, well, basically it's not. I mean, we're using the modern object Pascal as implemented by free Pascal Compiler. As I think mentioned, it supports generics, classes, and well, a lot of other stuff. And let's actually see how it looks like inside. So what I did right now is I double-clicked on the game state play source code, which contains the initial code of your play state, which corresponds by default. It's actually very flexible, but by default it corresponds to what you have designed in the stateplay.castle user interface. Okay, and what I can do right here, well, I can, for example, access some components using their names. Okay. So what did I call it? Button show message, right? So let me just go and copy paste it just to be sure that I won't make any typo. Okay, so we have button show message. Now, for now, I have to do it manually, this accessing of the components. We have a plan to, of course, make it automatic. But as you can see, well, it took me, I didn't count, but not much time to do it. So once I have access to the button show message from code, well, I can do anything I'd like to. For example, I can configure its caption. But, well, we already actually set the caption that makes sense, I guess. But just to show you. So message, new caption, all right? And well, what is actually more useful for us here is I can say what happens if you click the button. Here I just assign an event to it, which is just simply a callback. What happens when you click on the button? And I found it a useful convention. Call those things click something something. Now I'm going to press in Lazarus Control Shift C, which means that Lazarus will do code completion, which means that it will actually automatically figure out that, hey, what you wanted is you wanted to create a method called click show message. It plays the declaration of this method in the source code. And now what I have to do is simply fill it. So I'm going to use something that is, well, it's really mostly for the debugging, I guess, purposes, is that I'm going to simply use a message OK procedure that displays a very simple dialog box. So here it goes. Okay, I also want to add this definition of application and definition of message OK. The units that define those things, I want to add them, make them available to make this thing compile, and that's it. How to compile it now? Well, I can go back to the editor, I can do run compile. It's the same thing as pressing run and compile from the Lazarus. It's just the same source code using the source units, the same units. Let me do it from the editor right now, but it really doesn't matter. You can run your project on desktops from Lazarus. It's works the same way, it compiles the same thing. So you can of course use debugger using Lazarus. So if you develop using Lazarus, usually it's better actually to run the project from Lazarus. Okay, so here it is, play, show message new caption, and you clicked. I warned you that this is going to be like a very, it's not really a production, it's an ugly dialog box, okay, let's say it explicitly, but it's a simple way to showing that something works, okay? Okay, so this was a very simple demo that you can modify the 3D template created by the editor, and you can edit code there, you can add the resources from Blender easily, you can modify the user interface, and yeah, you can control what happens when you, for example, click on a button. Yeah, so this is about the 3-dimensional demo of our engine. Now, the next slide, demo in 2 dimensions. This is going to be a little bit quicker because I'm not going to pick it so much around as I did with the 3-dimensional demo. So let's go back, let's close this project and let's create a new one, starting from the 2-dimensional demo template. Of course, if you're worried about those templates like doing too much for you, remember that there's also always the empty template. So I guess you can treat those kind of 2D and 3D templates as kind of a nice starting point, I guess, for some games. But once you learn the engine, I guess it's probably easiest to just start from the empty template. Still, they are very useful for, as you can see, demonstrations. So here I'm going to use the 2-dimensional game. Okay. And again, it's like in the data file, I can find state play, which shows how the game will look like once played. Now, again, this is a viewport. It contains castle scenes. So the same thing as you saw in 3D. It's simply, by default, right now, it has a 2-dimensional camera that has orthographic projection. So it's something more useful for the traditional 2-dimensional games. You can always switch between 2-dimensional orthographic camera and perspective camera at runtime. This is all configurable using the camera properties of the viewport. You can say what is the projection type. You can configure all those projection parameters inside the orthographic or perspective sub-components. Okay, so as I emphasized, 2D and 3D, they are just playing very well together. It's just a matter of what is your default camera view. Okay, what happens here? Well, the same thing as we did before. So you can, for example, move things around. Let me move this dragon around. Well, it works. What can I do with it? Well, I can compile it for desktop. It will work. It's something that you've already seen. So let's actually go to something else. let's do something else, which means that let us make it running on Android, okay? Now, how to do it? Well, one way to do it is to, well, you will need to, one way to, well, basically to compile something for Android, you need Android SDK, NDK, and free Pascal compiler with cross-compilation option to Android. Now, one way to do it is basically a manual. It's explained in the engine documentation, of course, how to install all this necessary stuff yourself. But there's another way, and I'm going to show it to you right now, which is to use our Docker image, which is a ready-to-use Docker image that contains free Pascal compiler with various cross-compilers installed. It also contains Castle Game Engine with its build tool, command line build tool, and it also contains Android SDK and NDK tools to easily create Android APK. So let's try to do it. So this is documented in the Castle Game Engine documentation. Here I'm just going to copy paste the basic line how to use the Docker from Castle Game Engine. So because this Docker line is mounting my home directory inside the Docker image, so I can simply access my project by going here. All right, this is my project. Now I want to build it, okay? To build it for Linux, I would do this, okay? Compile by default simply compiles for the current operating system, which means Linux right now. But if I would like to, now what I want to do more is I want to package it, which means to create something distributable. And I also said that I want to create this package for Android, okay? And that's it. Now we simply wait. The build tool, as I emphasized, it simply uses the free Pascal compiler under the hood. None of what I'm talking about would be possible without free Pascal compiler. It's using the free Pascal compiler right now 2 times to compile the engine for 2 architectures, which is 32-bit ARM and 64-bit ARM, which means both CPU processor architectures that are used by the Android devices. Okay, and this command, once it finishes, it will just create a ready APK that you can transfer to your device in any way you like and run it there. And I'm going to show you how this APK works on the actual Android device. For this, I'm going to actually use the fact that this is a pre-recorded session, so I'm going to basically right at this point where I'm speaking, I'm going to paste a bit of another video that I will record on my Android device and showing you that it works. Okay, so right now, yeah. Okay, so thank you very much. I think this was all that I wanted to show you in this presentation about Castle Game Engine. I know that I started to speak very, very fast at some point, right? I started fast and then I went even faster, I think, along the way. So sorry about that. I hope it was comprehensible, basically. I hope it was understandable what I was saying. If you have any questions about the engine, please go ahead and ask them. We have a forum, Discord chat. I have a mail. I'm available for all the questions. I'm curious about your questions and yeah. Please feel welcome to use the engine. Here's the link. It's all open source. Please try it out yourself. And and watch out for the 7.0 release that we are going to make. I hope really, really soon, because we have been working on it for quite some time. Thank you. Thank you very much.
And welcome back. So we have a few questions. The first one is by Elbrus, and he asks, will version 7.0 be ready before the bullseye freeze?
Yeah, so basically, I wrote the answers on Etherpad, but I can kind of repeat them shortly here. So basically, we will be very close, and I kind of very, very much thank you for the suggestion in the Etherpad that indeed we should make an alpha release earlier. It's something that is already available on our webpage. I mean, we kind of treat the current master branch as a stable. It's actually used in production games. So I guess we should make a release like 7.0 alpha release in Debian and then update it on February. So thank you very much for the suggestions. Yeah, this way maybe we'll be able to do it.
So another question. Somebody asks, what is it like for developing free and open source software for the Switch, Nintendo Switch? Is it in the Nintendo store, or is it side-loaded?
Yeah. So to answer, to kind of to rephrase what I basically wrote is that, well, the problem with developing open source on Switch is that basically you cannot. I mean, the Nintendo Switch API is closed and has to remain closed because Nintendo, well, wants it that way. So the way we had to do it, we had no choice, is to make a closed source fork that is kind of under my supervision that contains engine with some small tweaks to make it work on Nintendo Switch. Well, it has to be closed source. We don't have a choice about it, but I kind of guarantee that it is available for free to anyone, but to anyone that is also a Nintendo developer. So to anyone that has also signed the Nintendo NDA. And then I guarantee you that I will make this engine like free for you. Just contact me through the Nintendo forums, because then I can kind of verify that you're also a Nintendo developer, and that is like cool with Nintendo then. So, well, that is the only way to do it. So that was how it was done.
And a final question: why is it called Castle Game Engine?
Yeah, that was the hard question. I don't know really. I just like castles. I like fantasy stories, and at some point it sounded like a good name for the engine. And now it stays because we have a lot of demos that actually show castles, but now it's like an effect, not a reason. Yeah, I like castles. I don't have a better answer.
Oh, well, that's it. Thanks for a great talk. It was really interesting, and thanks again for presenting.
Thank you for having me. Thank you.